Hi, Prashant.
Hello. Yeah.
You back today on time?
Yeah, on time today I could manage to come.
Okay, that's good.
So you don't have any batches on Saturday, Sunday, na? Because never you take
Mm.
or
Yeah, I take on Monday to Friday, but this time I am planning to have for only this weekend. I am planning to continue these classes. Let me check with other candidates if they are also available. Then I'll continue on Saturday and Sunday only for this week.
okay.
Okay.
Yeah, because traffic situations are very bad.
Mm.
Anyways,
Mm-hmm.
I have put
Which
a
city you are in?
Mumbai. I've asked my
Okay.
manager. He told me he will tell me like because
Okay.
traffic situations like 1.5 hour is minimum distance, minimum time you take to reach,
Mm.
even if you are 10 kilometers away.
Yeah. Okay, let us start. Meanwhile, others will join. Any questions so far from yesterday's session? Okay, let me share my screen. I hope you can see my screen, everyone. Yes, no? Can you see my screen? Anyone can confirm?
Yes, we can see your screen.
Oh, okay, fine. So, welcome today, and I'll just give you a quick recap whatever we have discussed so far. So, we started with learning why performance engineering is important, right? So, there are many things that that is required in industry. For example, your application has to be stable, reliable, available, right? All those non-functional requirements need to be met. So that is why performance engineering is important. So it needs to meet your speed, scalability, stability, right? So and it's not only about those, but it's only about creating cost optimized solution for your clients, for your customers, so that and I mean end user experience can be enhanced, right? Like I used one line on the very first session. Somebody's loss is others gain in today's world. That is how competition is. If you are buying anything on Flipkart and you don't find that UI satisfactory, then you will obviously go to another competitor like Amazon or any other website, right? So that is why performance engineering is important. And after doing the testing, if you have done engineering, if you have done tuning of your application, it will definitely help, right? So yesterday we saw one scenario where we saw high CPU utilization. Okay, so I am highlighting today what kind of operations can increase CPU. Okay, so this is very important because sometimes what happens, uh, we saw some situation, but we are not able to correlate it with CPU consumption. For example, you saw some database deadlocks, okay, and but at the same time you saw CPU was fine, right? Because something was in blocked state, that doesn't mean it will increase the CPU, right? So we need to understand this. kind of scenario, what kind of operations can increase your CPU. Okay, so that is why I have highlighted here. So this is very, very important. Mathematical and computational processes, those can increase your CPU. Okay, so when the code is actively calculating, okay, or it is thinking. So CPU increases when you're when the application is in thinking mode, not in waiting mode. Okay, so please remember this thumb rule. So, and there is a difference between compute versus wait. Okay, so computation again means doing some mathematical job, right? Sorting large data, serialization, GC pressure, any such scenario if occurs, that will increase your CPU. Okay, encryption kind of scenario will increase CPU very high, because encryption means something is in some other code format, right? Encrypted format. So it has to be decrypted so that it can be readable. So these kind of scenarios will bring the CPU at very to higher levels. But there are other conditions, like I mentioned, there are blocking states which will not increase CPU much. However, your application remain in inactive state because some resource got blocked, right? So we need to figure out something else. We need to check memory. In this case, we need to check threads, or we need to check database deadlocks in this case. But it is not always necessary. If there is a blocking state, you will get higher CPU. Okay, so please remember this. If there are any busy wait loops, okay, there are any nested loops, that is also going to increase your CPU, right? Is it clear? So yesterday what we did, we ran these three transactions, and like I have shown you, one of my endpoint is doing some mathematical calculation, right? So this was my endpoint. So it was doing some mathematical calculation, and when I ran this test. So let me start it again. When I ran this test, I found there is higher CPU on my system. Consumption was high, and that consumption was only due to this endpoint. How I verified it? I disable this particular endpoint, API slash CPU, and then I ran these two endpoints, API slash slow and API slash quick, and it was running very fine. Okay, so in terms of CPU, I could not find any significant usage by running these two endpoints, by these two APIs. However, there is significant increase in CPU by running this endpoint because it has some mathematical calculations running inside it. Okay, clear? So let's move ahead. Any questions so far?
Yes, I have
No.
a question.
Yeah, please go ahead.
Yeah, suppose you showed in the code that we have some mathematical calculations in the code. So
Yeah,
it's how, but it's unavoidable, correct? We have to add that.
it's
It is a
yes,
mathematical.
yes, it's unavoidable. That's correct. Yes. Yeah, go ahead,
Okay.
go ahead. Then I'll add. You go ahead first.
Then
What is
how
your doubt?
can we
Then
find a solution for this, like to lower the
yeah,
CPU?
okay. Yes. See, here the main aim of this exercise was to aware yourself what kind of operations can increase the CPU. Okay,
Okay.
so that you can pinpoint only those areas instead of spending time on other areas which are not related to the spike. Okay, so that was the
Uh-huh.
main aim of this exercise.
Okay.
Okay,
Okay. Got it.
yes, I agree. Yeah, I agree with this. You cannot remove if something is required in the code. If any customer has to search something, it has to search, and there will be n number of rows, and the sorting, right? All those things are going to be happen, and that will increase CPU.
Mm-hmm.
But what you as a performance engineer, what you can do, you can do indexing of your database. I'll come to those things. Okay, I'll come to those things in later sessions, and we will see those things in practical as well. Okay,
Okay.
so yeah, so what performance engineer will do, he will do indexing of that database so that whenever a query runs, it will run efficiently. Okay, without consuming much of the CPU. Now, what is indexing, how it works, how it can improve performance, that we are going to learn in later sessions.
Okay, okay, thank you.
Yeah. Okay. Other thing, what we have seen yesterday. So we were running this command, right? And these were the JVM arguments that we have passed, right? So anybody can, I mean, can anyone tell me how we should decide what exact values we need to pass by uh, when we supposed to allocate JVM size, JVM space, what value we should pass? Like in this case, I have passed 256 and 1024. Okay. So what do you think? Is this a random number? Is there any logic behind it? Anybody?
I heard like it's maximum 1/4 of your RAM.
Okay. Okay. That's fine. Sorry. Yeah. 1/4 of my RAM. Okay. Yeah. So that is one thing. Anybody else? Yes, that is valid point. Uh, one of the rule is 1/4 of your RAM. Okay. So if my RAM is let's say 4 GB, I should not allocate space more than 1 GB, right? So that is one point. Obviously, we can't guess, right? And that is not, I mean, if we are the engineers, there must be some logic, there must be, something behind to decide these values. So how to do that? That's where, importance of performance testing and performance engineering comes into picture. So what you can do, you can run a load test and monitor your heap usage. Okay. Then observe peak heap, observe GC frequency. Now, what I meant by GC frequency, this is GC frequency. You can see, right? So how many times the GC ran between this time frame? Okay, since I ran my test. So why, if you have noticed, yesterday the CPU was less, but today it reached around 35, 30, more than 30%. The reason is I am running test with more users this time. Okay, 40 threads. So that is why this graph is higher in range today. So this is GC frequency. So what we were discussing, how to decide these values. You can run a load test and then you can monitor your heap usage. Okay. And once you have, suppose you ran with your peak load, you can give 30 to 50% buffer. Okay. Suppose your peak usage was 700 MB. So you can give some buffer into it and you can allocate 1 GB. Right. Similarly, if your peak usage is going beyond 1 GB, you can allocate 1.5 GB like that. Right. Another point somebody mentioned, 1/4 of the RAM. Yes, that is very valid point. It should never equal to your server RAM. Okay. Uh, anybody has any questions on this? Okay, and few more important concepts here. If there are too many GCs going on, okay, so that means heap is very small. And if there are long garbage collection poses, that means heap is too big. Okay, so that is why garbage collection frequency comes into picture. If there are multiple GC frequencies happening, so that means your heap size is very, very small. If there are long garbage collection poses, that means heap is too big. So balance is the key. Fine so far. And anybody can tell me, is it recommendable, is it advisable to allocate both the sizes equal? What do you think? Is it advisable?
I don't think so because this GC will frequently hit if we go for same minimum and maximum memory.
Okay, so you are saying it is not advisable to give equal size because the environment is
Yeah, frequently.
Sorry, I can't hear you properly. Can you please come again?
Okay, what I'm trying to say is if we give minimum and maximum size as same, there could be a chance of hitting GC frequently.
Okay. GC frequently. Okay, fine. What
Yeah.
else?
And suppose if we give the minimum value less, then it will start from that value and it will not go unnecessary to the maximum value.
Right. So not equal is recommended when the environment is shared. Okay, suppose in dev or in test environments, sometimes you don't need, like somebody pointed, if there is a minimum allocation you have given, and in during your development or during your testing, you are not going to utilize your whole heap. So it is, it's better for shared kind of environments, but it is often recommended for production. Okay. Why? Because it can avoid heap resizing pauses. Okay. So whenever there is a equal XMS and XML, so that means it is already allocated some space, right? So you need not to resize, right? So whenever there will be a resize, there will be some pause, right? And there is some pause, that means there will be delay or there will be latency or high response time in your application. So that can be avoided, right? Better GC behavior, if both are equal, then it will lead to your better garbage collection behavior. Okay. So, but it is again, it depends upon application to application. So whatever I'm saying, that is more commonly used in low latency kind of applications or systems. Okay. Fine. Any question on
Yeah,
this?
yeah, I have a question on this one. So I work on the retail applications. So what I suggest from my applications to the development team from last couple of years, right? So always use the min and max size is equal. So
Hmm.
suppose my container size memory is 4 gig container size memory. Out of that, I will allocate 2 gig for heap size for min and max.
Hmm.
So is this the
Right.
good idea to suggest the values like that, or is there any other way we can suggest the values?
Okay, yeah, it's a good idea. Okay, so giving equal value is highly recommended in production where the environment is, only dedicated to the end users. If the environment is
Mhm.
shared among development team and test team, or there are UAT and performance and functional testing is going on the same environment, then it is not advisable. So
No,
your
so
suggestion is
we test it in the perf environment first, right? Whatever the
okay,
values we tested in the lower perf environment, we
hmm,
had to give the recommendations to go to the production, those settings only.
correct.
Ultimately, the
So
performance engineer is the key point to sign off these particular changes, right? So,
correct. So so when you say perf environment, that is dedicated to performance, right?
yes.
Yeah. So yes. So then it is a good suggestion. That's what I'm saying. Because see, if the environment is shared among different teams, then we may utilize unnecessarily RAM, right?
Mm-hmm. Mm-hmm.
You're getting my point, right? So
Yeah, yeah.
allocation is like, yeah. So let's say there is a hotel with 100 rooms, okay, and you have booked one single room, okay.
Mm-hmm.
So hotel space is, let's say, 100 by 100, and you have booked a room 10 by 10, okay.
Mm-hmm.
If you need only 10 by 10 space, then it is sufficient to you, correct?
Mm-hmm.
Nobody else. So suppose if you need more space, you can have more space allocated to yourself, but at the same time, if somebody need that,
Mm-hmm.
so on shared environments, I'm saying it is not recommended to give equal size, but if the environment is dedicated to your performance testing only, or
Mm-hmm.
if the environment production, then it is recommended to give equal values.
Okay, got it. Yeah, because
Yeah,
we always test before going to the production, we will not test it in the shared environment, right? Because we have to
correct.
ensure that whatever the settings we are suggesting to match with the production. So,
Yes, that's right. So your suggestion is good. Okay, so yeah, so this is the table you can refer. So I'm gonna share this as well. I'm gonna share this document on the same drive. Okay. So production stable workload, yes, recommendation is equal, low latency system equal. So if test environments, right? So if there is a dedicated test environment, you can give it equal only in that case if you're doing performance testing. But for functional or for automation, that is not required, right? Because they don't need to run load test, correct? Any question from anyone? Okay. So yesterday we set some variables, right? Environment variables. We set uh, bin folder, JDK, all those things, and I was using one term JVM again and again. So I want to clear few things. What is JVM? What is JRE? And what is JDK? Anybody is aware? Tell me in simple terms. Anyone? Okay, see, technically, this is the function of different comments. Okay, JMGRE and JDK. I simple analogy so that you won't forget it and it will be there in your mind forever. JDK is a superset. So it contains your JRE and JRE contains your JVM. So JDK means let's take an example of your kitchen. Okay, so JDK means in kitchen there is a chef and there are tools to prepare a food, and this is also a stove to cook your food. Okay, so JDK means everything. So it's a whole development kit with somebody who can cook your food, something which needs to cook that food, including your tools and including that gas stove. Okay, and JRE means kitchen only with stove. Okay, so there is no chef. And JVM means stove that cooks food. Are you getting my point?
Okay, so
So basically,
it grows on, like each is the subset of
yeah,
the other. Like,
correct. Each is the subset of the other. So basically, this is the engine. Okay, so in my analogy, stove is the engine, right? Stove is the final engine where we are preparing our food, right? So JVM is the engine that runs our bytecode. Okay, so this is Java virtual machine. Fine. Then there is a JRE, which means JVM plus all the supported libraries. Okay, it includes your runtime files, it includes your Java libraries, but there is no compiler inside JRE. Okay, in JDK, so in the final this Java development kit, you have JRE plus the tools. Okay, so it is the final thing that is used by developers to build applications. So it has compiler, it has JRE, it has debugger, everything. Fine. So development kit comes with everything. So if you go inside my bin folder, let's say, let me go inside JDK bin folder. Okay, so you can see all this DLL. Also, see earlier Java gives JVisual VM as well, but now it give only JConsole. So JConsole is also one of the debugging tool to analyze your heap and CPU, everything, right? So see, JDK comes with the whole development kit, right? It includes your runtime environment plus it includes your tools. Fine so far? Please say yes, no, or maybe.
no, yeah, yes, sir. Totally understood. I mean,
Okay,
JVM,
okay,
JRE, and JDK. Yeah.
okay. Now let us learn the JVM architecture. Okay, how it looks like and what it does. Please feel free to ask if anybody has any questions.
Yeah. So is it JVM? Is it uh, similar to that .NET virtual machine? Like Even
That's
that
right.
.NET platform also, because I'm from I was a .NET developer for 5 6 years, so I relate everything to that
Okay.
.NET stuff. Is it similar to that, like the .NET
Correct.
runtime environment?
Correct. Correct.
Okay. CLI,
Conceptual wise,
CLI,
it's
and yeah.
yes. Okay, so JVM architecture, I mean, whenever you run an application, okay, yesterday, so what we will do, we will see practical and we will also learn theory side by side. I'll do one thing. I have one heap dump with me. I took some time back. So this is a heap dump looks like. Okay, so currently I'm taking heap dump using JVisual VM, but I'll also teach how to take this dump using command prompts. Okay, that we will learn in upcoming sessions. So what I want to show you is, let me go to objects. Yeah. So whenever I run any application, right, there are many objects gets created. Object means, let me go to my Java code. So it has these different APIs, and APIs has further actually the classes, right? So whenever I run this, it create an object, right? Object of a class gets created, right? Initially, every object gets created in this hidden space. Okay. So basically, the whole architecture is divided into these three generations: young, old, and perm gen. But with the current Java versions, Java 8 and plus, there is no permgen that is replaced by metaspace. So that is why you can see here, if you go here, you can see this, right? So heap and metaspace. Heap means, so now this graph is showing me young generation and old generation. This graph is showing me these two space. Okay. Whenever a new object comes
Okay.
into picture, it gets stored inside
Huh.
hidden,
एक minute, एक
hidden
minute.
space, right? So after some time, object moves to survivor space. If those references are no more required, those are no more live objects, right? So you heard about these term, right? Garbage collection, what all objects gets cleared, who are not alive, right? And whatsoever the objects that left out after the first minor GC cycle, that moves to survivor space, right? Now, how to decide this and what argument we can use, I have also shown here. So there's a one term called survivor ratio. Okay. So if you are setting your survivor ratio as 8, just an example. Okay. If your survivor ratio is 8, that means your hidden survivor 0, survivor 1. Okay. That allocation will be in this ratio, 8:1:1. Okay. So if your survivor ratio is 80, so that means this is 80, this is 10, this is 10. So that's why it will be total 100. Make sense? So this is how this survivor ratio is decided. Okay. Now minor GC is running across this young generation. Okay. And all the objects which are left out, which are not, released throughout this minor GC, they get moved to old generation. Okay. Which which objects remain alive? Something like, suppose you are logged into the application, you have logged in your Gmail. Okay, some session ID get generated, you are sending some email, you are receiving some emails, you are checking those emails, right? Unless or until you log out from your session, there will there will be always one object related to your session ID which will always remain alive, right? That is not get cleared by the garbage collector throughout the time duration whenever you are live on your application. right? So that kind of objects move to old gen. Make sense? Now, if the objects remain in old generation for longer duration and then it got released, when it who is responsible for releasing them? The major GC. Okay, so major GC happens in this area. Okay, so major GC is actually all the objects which survive this space but move to this space gets cleared by major GC, and frequent major GC is a problem for your application. Frequent minor GC is fine, but frequent major GC means actually major GC can cause stop the world. Okay, you must have, if you are already from performance background, you must have heard this term, stop the world. Stop the world means there will be a big pause in your application for that moment when that GC runs. Okay, so if the application is not designed in good performant way and JVM has to run major GCs, that means memory management is not correct. Are you with me, guys? Yes, no?
Yes, yes, sir.
Any questions so far?
Yeah, where you showed that setting like that ratio. So where can we set it in the JVM folder or somewhere else?
Yeah. Uh, if you remember yesterday, we ran this command, right? So you can send that argument in the command itself. If you are running your application, okay, you can set that argument. Or if you want to, I mean, so this is one way, okay? By
Mhm.
setting your JVM argument, this is one way.
Okay.
Is that fine? Is that answer your questions? Because these are the JVM arguments we are sending here, right? And
Okay,
all
but
these
if I
JVM
want to
arguments, you can.
make
Hmm?
make in some add it to some file, then it will be in JVM folder of Java or somewhere else.
Yes, yes, it will be in JVM folder. Yeah. We will, if you want, we will try it practically and I'll show you. Fine?
Okay, okay. Yeah.
Yeah. So these are the, if you can see here, these are the arguments currently I'm sending, right? So since I'm explicitly defined these arguments in my command, so you can see only this much in here, right? So whatever you define, whatever you explicitly define while launching your application, those arguments are visible under JVM arguments tab. Fine. Make sense? Okay, now let's come to
Yes.
this thing. What gets stored inside heap and what gets stored inside metaspace? Okay, so all the object related information, suppose this is heap dump, right? So heap dump means it has no information related to metaspace. Okay, so heap dump means it has information only related to heap. Okay, and don't get worried much about the metaspace because JVM itself handle it, JVM itself take care of it. Okay, so as the things get progressed, there are new innovations. That is why I showed you after Java 8 there is no permanent generation kind of thing, right? We used to call it permgen, so that is not there now, so it is replaced by metaspace. Okay, now JVM is taking care of metaspace by itself. You need not to worry about it. Okay, so that is how improvement happens over the time, right? So heap stores your object instances. Okay, it stores your instance variables, all the non-static, whatever arrays, whatever objects you create at runtime, all those strings, those get stored inside your heap. Okay, so if you are seeing anything increasing here, that means your objects, your arrays, all those things, right? those are getting created and using that space. Okay, how much it can use? It can use up to 1 GB. That's what we have defined here. Okay, so heap stores all the object instances. Please remember it. It stores all the instance variables, non-static instance variables. It stores your arrays, your strings, whatever you create at runtime, it gets stored inside heap. Okay. Now coming to Metaspace. Metaspace has a information about your classes. Okay. It does not store your class objects. Okay. It is like a recipe book. Okay. I'll give you same analogy of kitchen. Heap is like your refrigerator. Okay. And hidden space that we are talking about here, hidden space, imagine it as your fresh vegetable section. Okay, which is newly since we are saying it contains newly created objects. So imagine it as a fresh vegetable section. Then survivor space, those you have already washed, the veggies or any vegetables a bit older than your fresh vegetables, that is under survivor space. Okay, so imagine old generation as your frozen things. Okay, and which can be stored for long term. Okay, and metaspace is your recipe book. Okay, it has all the information what you can do with all those things. Okay, whatever is inside your refrigerator, what you can do, all that information is inside metaspace. Got it? Shall I explain it again?
So it is same like the generations in in the .NET stuff, like generation 1, generation 2, generation 3. I mean, I uh, just trying to understand this. Uh,
Yes.
okay, got it, got it.
Yes, yeah. Okay, so that is how it works. I'll give you that. Yes, here. So this is my heap dump. Now, what will I'll give you a high level idea of heap dump today. We are going to do a deep dive analysis of heap dumps, and we are also going to see some scenarios where out of memory kind of errors will occur and your heap usage will increase, and explicitly you need to run your garbage collections. Okay, so we are going to run those tests in upcoming sessions. Okay, so I'll give you a high level idea as of now. So heap dump contains all the objects related information. By looking at a very first instance, what do you think you should look at it? Okay, now this is heap dump. You taken a dump, you open it, it is what looks like. What will be your first guess? How will you deduce anything? I mean, any information out of it? Anyone?
That size is size of the specific object, like hash map node, that is very big.
Okay. Anyone else? Yeah.
Count as
Okay. Okay. So whenever we talk about heap dumps, right? So basically you need to compare it. Okay. What was the situation of your memory before the test? What is the situation of your memory during the test, and what is the situation after the test? Now this count and size, this is very important to see here. So don't get confused, don't get overwhelmed by looking at those lot many things. For you, for as a performance engineer, these 4 5 lines are sufficient for us. Okay, this is sufficient for us to understand what is going behind. Okay, now you can see if you compare this heap dump. Now let's say I have taken this heap dump after the test. Okay, and before the test, let's say my count was around 400 for this particular byte object. It was around 400, and it is now 583. Now I'll again take an dump, let's say after 10 minutes or 15 minutes of my test duration, and I found the count is still the same. Okay, so that means those objects, I'm not running any test now, right? There is nothing going in the from our end, but still that count is not getting reduced. So what does that mean? There is a very I mean, a term that we use in performance for which we do endurance tests, if you remember.
Memory leakage.
Yeah, memory leakage, right? So if these counts are not getting reduced even after your test got stopped, even you are not running any load test, so that means there is a memory leakage. There are few objects which are not getting cleared by garbage collection. Why those are not getting cleared? Because there are still references found by JVM, right? So how JVM works, it automatically releases, right? It automatically clears. But if it found some references to those objects, means it is assuming those objects as live objects, and that is why it is not clearing it. So that means there is a memory leakage, right? And we are going to test that memory leakage scenario in our later sessions. We will introduce some explicit fault in our application and then see how it, you know, uh, make that memory leakage. So coming back to what I was saying, you need to look at these count and these sizes. Okay. Any question so far on it? Please feel free to ask, guys. Otherwise, I don't know whether I'm able to clear these things. I'll not get that. Things are clear? Yes, no?
Now, suppose we want to report it like this byte object is taking like it has a lot of
Hmm.
memory consumption, then
Correct.
so under that too many bytes are there, correct? So exactly what we can conclude from
Correct.
this.
See, that's a very good question. So not too many objects, but all those objects are related to same application. First thing, right?
Okay.
Now, what you can report it, sorry. So what you can report from here is, first, this particular object has a problem. It is not getting released by our garbage collection. Then you will find some information inside these references, right? Now,
Mhm.
if some developer looks at it, he can very well understand, right? Because he is the owner of that application, right? So he will very well understand, okay, which particular method is calling it, right? Where that problem can be, right? So
Yeah.
if you provide this, if you provide this whole information, then it will be very beneficial, right? So you
Okay.
can see, yeah, so you can see the whole reference chain here, right?
Yes, sir.
Okay.
So first, yeah, so the high level thing you need to look at is count. And after that, you can drill it down. Okay. And you can find some now this is a sample application, right? But in your actual objects, you will find some names, you will find something related to your method so that you will understand, okay, this may relate to this transaction, this may relate to this operation, right? Like that.
So there is showing the count as 583. So we can see like 583 entries like this, correct? Byte.
Yes, so these many objects got created. Which type of object? Byte type of objects. So total 583,000 objects of these byte type gets created. So when I
Okay.
took the dump, yeah, when I took the dump inside the heap, there were 583,000 byte type of objects living, okay, at that particular time when I took this dump at this time.
Okay.
Yeah. So that's why I'm saying we need to compare these dumps. We need to compare these dumps before the test, during the test, and after the test. Okay. And if you actually, while running the test, it is not advisable. You can take one snapshot, but not more, because it may have some overhead on the test. Correct. So if there is not uh, clearing of these objects even after some duration of your test, then there is definitely a memory leak. Okay. So in upcoming sessions, what we will see, we will introduce memory leak by injecting some fault in our application. Okay. This was a sample application that we were testing yesterday. But in later sessions, there will be some complex application that I'm going to use, which will be a 3-tier application. It will have a separate web server. It will have a separate application server and separate database server. And the bonus point for you all is I'll be using containers, Docker containers, and we will also learn Docker side by side. Okay.
Okay.
Sir, one question. I mean,
Yes, please.
uh, sorry to ask, but what this visual VM, is this a separate tool? Because or
Yeah.
or
Yes. This is a separate
is
tool.
it
So
it
yeah.
comes with Java, this thing like for the Java
Earlier,
package, or
earlier it used to come inside Java package, I think till Java 8. But now you have to have this explicitly download separately.
okay, okay, it is
Okay.
visual VM
VM.
2.2. Okay,
Yeah.
okay.
Yeah. There is one
Virtual,
more tool.
okay.
Let me.
And
Yeah.
how do you
In
configure it
Java
with
package,
your
there is
in
one
Java
more tool.
application?
Okay. Let me show you. So I am terminating my application. Okay. I'll run my application again. So let us see how it looks like now. So currently you can see, right? It is showing me. So these are my local JMX. Okay. It is showing me two Java processes. One was related to my application, demo load application, which currently I have stopped. It is not running now. Another is Jmeter. Since Jmeter is also a Java based application, it is showing me that name here.
Okay, so
Okay.
Jmeter
Yeah.
also we are using. Okay.
We are not monitoring it, but by default, whatever is Java based, this will catch it. Okay.
No, but how did we configure this particular? For example, I have done Dynatrace installation. So in Dynatrace,
Uh-huh.
we actually go and install that exe. I mean, run that stuff on and then configure, do that some basic configuration, and then the
Mhm.
tool is embedded to that application. I mean, you need to install some Dynatrace
Mhm.
stuff on that machine, okay,
Correct, correct.
where that
So
application
for
runs. Over here, where
right,
did
those
we install?
agents.
So how did we how see there is like what I understand, there is one agent or one server agent, what is or the one
Correct,
agent in Dynatrace. That one agent
correct.
will be installed on the server. That one agent will take that information, put it on the central Dynatrace server, from where we will get the information. So here how it uh, virtual VM, how
Yeah,
it,
right.
I mean,
So
sorry to
in case
disturb
of
you, but yeah,
Dynatrace, no,
yeah,
that's fine. In case of Dynatrace, you are right. We need to install those agents so that those agents can pull the data from application and we can see on the dashboards, right? But
yeah.
this tool, you can simply, if you download it, Okay, it's a simple Java application again. Go to bin folder of this JVisual VM and then open this application. Okay, so you need not to install any separate agent for it. But when you open it, you can see these options. Okay, local, remote. Okay, so these
Hmm.
two important options you can see. If you want to connect some remote application which is running on your remote host and you have access to that host, okay, you can give that IP. So when we go to our Docker containers, I'll be using this one, okay, remote host. But currently, since my application is running on local, okay, so I have not started it. Let me start it again. So you will find, so currently you can see there is disable this is disabled right now. Have you seen this new application comes here? It was not there earlier, right? Now it comes here, right? So as soon as I start my application, it start reading that. Why? Because that is how it is built. It read all. I mean, it start pulling the stats from all the Java based applications running on
Okay,
my
okay. So if
system.
your
Jmeter
if
is,
your server, yeah, yeah. Okay, go ahead, go ahead.
yeah. So if suppose I don't want to monitor the Jmeter, but it still shows me here. Okay. Why? Because this is also Java based. So whatever Java based applications are running on my
Okay, okay,
system,
got
it
it.
will
So
automatically
whatever is
connect.
there on the server, Java base, it will pick it up and it will start
Yes,
showing it. Okay, got it, sir. Got it.
correct, correct. And there is another tool that comes with Java package that is called as JConsole. Okay. So similarly, if you see here, let me show you. So you can see the process or ID of my application is 23852, right? So you can find the same PID here. Okay. And so 23852. Can you see this? 23852. So you can see this heap memory, threads, classes, CPU, right? So this
Okay.
comes with Java package, JConsole and JVisual VM. Earlier it used to come, but now you have to install it explicitly.
Okay, so this is free. J console
This
is
is free.
free.
Yes, these are open. Both are free.
Okay, JVM, that tool also is free, but you have to install, you have to download it separately.
Correct, correct. So you can simply go to Google and type download Visual VM. If you want, I'll do one thing. I'll zip it and I'll share you on that drive itself, so it will be readily available for you to use.
Okay.
Okay, okay, guys. We'll start working and we'll start seeing some faulty codes in our upcoming sessions. And we will also learn about threads, processes, and programs. What is the difference between these three? Okay. And if you have any question, please feel free to reach out. And like I said,
Yeah.
currently uh, we can take we have taken dump using this UI tool, but tomorrow I will show you how you can take dumps using command lines. Okay.
Okay. Yeah.
Any question, anyone?
Okay. Oh, no.
So it's
Yeah, Sai.
I just want to connect with you for few minutes post this call. How can I connect with you?
Okay. You have my number, right? WhatsApp number.
Okay, I actually just joined today.
Okay.
Yeah.
Are you there in the group?
Yes, yes.
Okay. We can connect over WhatsApp or over call. Yeah.
Sure, sure. Yeah.
Okay.
Thank you.
Okay, everyone. Let's catch up tomorrow, same time. And is it okay if everyone is available? Can we continue classes in during this weekend? Because this Saturday, Sunday, I have some bandwidth. So if you all are available, yes, no. Okay, fine. I think people are not available. Bye.